Good morning, everyone. I'm Uma Maheshwari, APEEE Department, R&D Engineering. Good morning, everyone. In this video, we are going to discuss about the subject Special Electrical Machines. The subject code is E8005, and the topic of discussion is Switch Reluctance Motor, Unit 2. So, the introduction part of switch reluctance motor. So the switch reluctance motor has wound coils. It is an electromagnetic and device which converts electrical energy into mechanical energy. It is self-starting motor, and here in the switch reluctance motor it has wound coils of DC motor for its stator winding and no coils or magnets on its rotor. So both the stator and the rotor have silent poles. Hence the machine is referred to as doubly silent machine. Now, by sequentially switching currents in the stator windings, the rotor is rotated. The movement of the rotor, hence the production of the torque and the power, involves switching of current into the stator windings, and there is a variation of reluctance. Therefore, this is variable speed motor drive and is referred to as switch reluctance motor. So this switch reluctance motor, it is a direct derivative of the single stack variable reluctance stepper motor, in which the current pulses are phased relative to the rotor position in the continuous rotation mode. Now about the construction of the switch reluctance motor and the configurations of the switch reluctance motor. So in this configuration, it is classified, SRM is classified as rotary SRM and linear SRM. Rotary SRM is again classified as radial field SRM and axial field SRM. The axial field consists of two configurations, that is the single stack and multi-stack configuration. And the rotary radial field of consists of basic structure which is doubly silent, and there is a short flux path machine. There are two types on it. Now discussing about the construction of the SRM. So the stator, it consists of a cross-sectional view of SRM. Here you can see a SRM with 6 stator poles and 4 rotor poles. The stator is made up of silicon steel stampings with inward projected poles. The number of poles of the stator can either be an even number or odd number. Most of the motor have even number of stator poles. All these poles carries field winding or stator winding. The field coils of opposite poles are connected in series such that their MMF are additive. Yeah, and the structure of an active rotor is called as phase windings. The phase windings are connected to the terminals of the motor. Now, with respect to the rotor, it is also made up of silicon steel stampings with outward projected poles. The rotor shaft carries a rotor position sensor. The turning on and off operation of the various devices of power semiconductor switching circuits is influenced by the signal obtained from the rotor position sensor. And here, in this switch reluctance motor, the number of poles of the rotor is different from the number of poles of the stator. Now, with respect to the block diagram of switch reluctance motor, this represents the block diagram of switch reluctance motor. DC supply is given to the power semiconductor switching circuit, which is connected to the phase windings of switch reluctance motor. The rotor position sensor is mounted on the shaft of the switch reluctance motor, which provides the signals to the controller about the position of the rotor with respect to the reference axis. This controller collects these information and also reference speed signal suitable and it suitably turn on and off of the power semiconductor switches of the switching circuit such that the desired phase winding is connected to DC supply. The current signal is also fed back to the control circuit to limit the motor current within the permissible limits. Now, with respect to the principle of operation of the switch reluctance motor, so here you can see that the stator pole axis A dash and the rotor pole rotor pole 1 and 4 are in alignment. So there is minimum reluctance position for as far as the phase winding is concerned. So in this case, the dLA by dt is 0. At this position, the inductance of B and C and D winding is neither maximum nor minimum. Therefore, there exists dLA by dt. Now the phase B is energized. Now the phase B is energized. Then the rotor rotates through a torque because of the variation of the inductance, and the torque developed is equal to half I square dou L by dou L to the suffix B by d theta. This direction of torque is such that dB dash and the rotor poles 2 and 5 is trying to get aligned. And if this torque is more than the opposing load torque and the friction torque of the rotor starts rotating. When the shaft occupies a position such as B, B dash and 2 and 5 are in alignment, that is alignment, the torque is developed in this position, dou L by dou theta is 0. Now the phase winding is switched off and the phase winding C is turned on, and the rotor experiences a torque as dou LC by dou T exists. Motor continues to rotate and the motor further rotates for another 15 degrees. The torque developed due to the C winding is 0, then the phase winding is switched off, and again the supply is given to the D winding. In the same manner, after the D winding, the A phase is energized again. So the rotor experiences a torque and rotates for every step of 15 degree, which is continuous and cyclic process. Thus the rotor starts and it is a self-starting motor. As the speed increases, the load torque requirement also changes. When the average developed torque is more than the load torque, the rotor accelerates. When the rotor torque balances, the rotor attains dynamic equilibrium and the motor attains a steady state. So at steady state condition, the power drawn from the mains is equal to the time rate of change of stored energy in the magnetic circuit. Now when the load torque is increased, the speed of the motor tends to fall so that the power balance is maintained. If the speed is to be developed at the same value, the developed torque is to be increased by increasing the current. Thus more power is drawn from the mains. Thus electrical to mechanical conversion takes place. So this video we have gone through the introduction of what is switch reluctance motor and the classification of switch reluctance motor and the construction and the working principle of switch reluctance motor. Thank you everyone.